Hello everyone, today we'll talk about chapter 9.3. This is the concept of similarity. In the last two sessions, that is the chapter 9.1 and 9.2, we talk about the concept of congruent, right? Congruent. So for example, in the following there are two triangles, ABC and triangle PQR, right? And they are congruent. That means the two triangles are totally the same. That means when we put the triangle PQR to ABC, the corresponding angles or the corresponding sides are all the same, right? You can see they are totally the same forever, the angles or the sides. And P will be corresponding to A, Q will be corresponding to B, the point R will be corresponding to C, right? So we can write down in this way, triangle ABC congruent to triangle PQR, right? This symbol. So in this chapter, that is 9.3, we talk about another concept, that is similarity. Similarity. What does it mean? First of all, similarity, usually when we say two figures is similar. First of all, the shape are the same. The shape are the same. What does it mean? For example, we have two triangles here. You can see the shape are very close, or we can say the shape are the same, right? Just the size are not the same. One is bigger, one is smaller, right? For another triangle, for example, I'll draw a right angle triangle. You can see the shape are not the same between these two, right? So we will not say these two are similar, but we will say these two are similar, right? So the shape. Later I will talk about what is the meaning of the shape, because this one is just a feeling, right? Just like feel, oh, they are almost the same, right? The shape are the same, okay? So for second, we will talk about the size. The size, you can see, they may not be the same. One may be bigger, one may be smaller, but actually, they can be the same. Later I will talk about it. Okay, so the most important part is that the shape is the same. But the shape is just like a feeling, right? We are going to use some mathematics method to analyze how can we judge whether the shape are the same or not. So I use the above two triangles as an example. For PQR, usually how can we make a similar figure? Just like the figure before, we can make a smaller or bigger one, right? For example, we can make a bigger one, or we can make a smaller one, right? You can see the shape between the PQR and ABC are almost the same, right? We can say the same. So this time I make a smaller one because the original ABC is large enough this time. So I put the Q points here, the R points here, okay? So they are not congruent again, right? Because the sides are not equal, right? So we want to do some comparisons. For example, I put the triangle to ABC. Let's see what we can see. For the angles, you can see the blue angles are the same. For the red angles are also the same. For the green angles are also the same, right? That means all the angles similar. All the corresponding angle. That means blue angle to blue angle, red angle, green angle to green angle are all the same. Right? Totally the same. That's the first property. Okay, similar. This one is talking about the property. For the second one, we are looking for also for the size. For example, this one. For PR to AC, you can see, and this time I make it become just like a half of it, right? Just like a half of it. That means when we put a point here, it's just like 1 and a difference. Maybe I change the size smaller, a little bit smaller. Okay, try again. Okay, I think this one is better. Let's see. 1 and 2. Oh, better. Good. Okay, you can see that means if this one the length is 1, if this one is length is 1, then this one is 1, this one is 1. That means this side is 2, right? Oh, I mean, we are giving more bigger. 2, 2. This one is 4. This one is 2, right? For example, this one is 1. I think approximately here. So let's see the ratio is also 2 times or not. Q out 1 times and then 2 times. Oh, beautiful. You can see, right? Q out is just 1/2 of BC, or you may say BC is 2 times of Q out, right? For P out also 1 times, 2 times. And then how about PQ? I think we're also the same. For example, I think this part, that is, you can see, 1 times. Oh, I'm not the columns, not really the place. Should be this one, right? Again, 1 times PQ and then 2 times PQ. You can see. So you can see all the lengths are in the same ratio. Ratio in Chinese called 比例, right? This time there are 2 times. That means if this one is 1, and then we know that this one is 1, this one is 1. So the total is 2, right? This one total 1, total 2. P out 2, then AC will be 4. If PQ is 2.5, we know that we have 2 times 2.5 here. That means this time will be 5, right? All of them are in the same ratio. That is the 2 times. So we can say all the corresponding side have the same ratio. That is, this time we can say, usually in ratio, 2 times is how can we get the ratio is BC divided by QR is equal to 2/1 is 2, right? So we can say A, B divided by PQ is, you can see is 2, right? Because I give you more. A boy is 5, PQ is 2.5, so we have 2, right? And I cross out this part. And then for A, C, P out will be equal to 4 to 2 is also 2 times, right? For the last ratio, B, Q, to green one, B, C corresponding to R will be equal to 2 to 1 is also 2, right? You can see the ratio are the same, right? So we can call these 2 triangles is similar. And the symbol this time will be this one. You can see it's just like congruence but do not have the equal sign on the bottom. So in these 2 figures, we can say triangle ABC is similar to triangle PQR. And don't forget that the order is very important. That means A should be corresponding to P, and the B should be corresponding to Q, and the last point, C, will be corresponding to R. The order is very important. Understand? And then I want to talk about one more concept, then we'll finish this video. And now I've already talked about what's the meaning of similar. That is, the shape are the equal, and how can which property we have get when it's similar. That is, the angles are all the same, and the side will be in the same ratio. That is this time is 2 times, right? 2 times. And I want to talk about that the ratio may not be 2 times. Sometimes maybe 3, maybe 1/2, and also I talk about some special case. That is when the ratio is 1. Ratio is 1. Ratio is 1. That means the 2 triangles, in fact, are totally the same. That means, for example, I use this triangle again. I make a copy. You can see these 2 triangles are totally the same. We can talk here about, we can talk them is congruent, right? But look for them. The 2 triangles in fact also satisfies these 2 properties, right? The first one, the angles are the same, right? The second one, the ratio, in fact, we have also the same ratio. For example, this one is the same. That means the ratio should be 2/2. That is 1, right? For this one, is 4/4. The ratio is also 1, right? For the last one, is also 5/5 is 1, right? So we can see the 2 triangles, when they are totally the same, they also satisfy these 2 properties. That means we can say that when 2 triangles or 2 figures are congruent, then it must be also be similar. Okay? When the 2 figures are congruent, then the 2 figures, we can also say that is similar. But on the other hand, they are similar may not imply the figure are congruent. Only when the ratio is 1, then we can say the figure is congruent, right? So be careful. These properties, I want to talk about this. Then for how to write down the step or do the exercise, I will talk about in the next video. Okay?